here's a little puzzle for you. See, here's an ice cube, kind of what's left of it. It's sort of melted. And I'm putting it there in this glass of water, and I want you to use this string to take it out.
Well, I've read about it in a book, but...
Oh, you've read about it?
Yeah, but I've never tried it.
You've never tried it?
No.
Well, first of all, you're supposed to try to take it out with just the string.
Okay.
Kind of tough, you think? Try
Yeah.
it. See if you can pick it up.
It won't work.
Forget it, right?
It won't work.
So how are you going to get it out?
Well, first, I need some salt.
Salt?
Yeah.
Plain, ordinary, everyday salt?
Yeah.
Okay. Salt.
Okay.
Now what do you do?
Okay, then I sprinkle. Well, first I lay the string on the ice cube.
Right on top of it, right?
Yeah. And then I put a lot of salt on it.
Mm-hmm.
On the string and the ice cube.
Mm-hmm.
And then you have to wait for a few minutes.
Mm-hmm. Right, what's going to happen?
Well, the heat, well, it's going to...
First of all, why do you put salt on the sidewalk when it's icy?
To melt the...
You know why
snow.
it melts it? When the salt goes on top of the ice, some of it melts on the water on the top of the ice, and salt water freezes at a lower temperature than regular water.
Okay.
So that's why it melts it. But in this case, as the salt is dissolving in the water around the ice cube, it's taking heat away from the water that's in the string. So it's very important that the string be wet.
Okay.
So that, in effect, the water in the string is freezing it to the ice cube. That's the theory, right?
Yeah.
Okay, if that's the case, you think we've waited long enough?
Yeah.
Here is a string. Slowly pull it up. Let's see if what you did was correct. Ha-ha!
It's stuck on.
Yeah, it's stuck on. It actually froze on, right?
Yeah.
So now, even though you just read it in a book, now you've really done it.
Yeah. It's pretty neat.
Yeah.
Jeff! This is a wave tank. Hit it! Looks like the waves are just moving from one side of the tank to the other. Interesting observation, Izzy. What do you guys think would happen if I take this ball and put it into the wave tank?
I think that it'll move with the wave from one side of the tank to the other.
I think it'll just bob up and down. Let's find out. Nailed it.
It's moving up and down, but not in the direction that the wave is moving.
Exactly. Matter doesn't move through waves, only energy does.
Hello class, I'm so excited you're watching this video. I hope it helps you a lot. Alright, this location's pretty easy to figure out. I'm in the ocean because we're talking about oceans in science. Alright, and today specifically we're talking about salt and waves. Alright, so we're on pages 184 and 185 in your science book. Alright, let's talk about the videos you just watched. So the first video with the egg floating. Why do you think the egg sank in the first cup with just regular fresh water and floated in the second cup with salt water? Well, it has to do with density. Okay, so the density of an egg is higher than the density of tap fresh water, so it's going to sink. Now, when we add the salt to the water, like in the second cup, the salt water solution density becomes higher than the eggs, so then the egg floats. Okay, so what that's really saying is in the first cup, there's less molecules than in the second cup with the salt water. Salt water has more molecules, so it causes things to float easier. Okay? All right, well, I hope you enjoyed those experiments, and I hope you have a fantastic day. Bye!